You ever walk through the city on a really hot day and it just feels like an oven?
Oh, absolutely, like a pressure cooker.
Exactly. But then you drive just a little bit outside and suddenly it's noticeably cooler.
Yeah. That's the urban heat island effect we're talking about. It's a real thing.
Uh-huh. A measurable difference, sometimes several degrees Celsius hotter right in the city center compared to, say, nearby rural areas.
And it's not just, a vague feeling. It's baked into the city itself. The concrete, the buildings, the asphalt, they all change how heat behaves.
Right. So for this deep dive, we're digging into a pretty major study from 2011 by Pang and colleagues. They looked at this on a global scale.
A really global scale. They analyzed 419 large urban areas all over the world.
Wow, 419. So what was the goal? What were they trying to figure out?
Basically, the mission was to uncover the main reasons why some cities heat up way more than others. What are the key drivers?
And they used some pretty sophisticated methods, right? Satellite data.
Yeah, exactly. They used MODIS satellite data. Think of it like a giant thermal camera in space, measuring something called surface urban heat island intensity, or SUI.
SEII. Okay, so that's not quite the air temperature we feel when we step outside.
Not exactly. SEII measures the land surface temperature, so the temperature of the actual ground, the roads, the building roofs.
Okay, the surfaces that are absorbing and then radiating that heat.
Precisely. And that surface temperature is obviously closely related to the air temperature we feel, but it's focused on where the heat is being held and released.
Got it. And why should why should our listeners care about this SUII stuff?
Well, it has huge knock-on effects. Think about energy use, how much more air conditioning cities need.
Right, AC bills go way up.
Exactly. And it impacts air quality, water quality, even our health directly during heat waves. Understanding this is, well, it's crucial if we want to build smarter, more livable, sustainable cities.
Makes sense. So they scanned these 419 cities. What were the sort of big picture findings? Did most cities show this heating effect?
Oh, yeah. Over 90% of the cities they looked at were warmer than their surroundings. On average, the annual daytime SUHII, the surface temp difference, was 1.5 degrees Celsius higher in urban areas.
1.5 degrees hotter during the day. And at night?
A bit less, but still significant. About 1.1 degrees Celsius hotter on average at night.
Okay, so cities are generally hotter day and night. But here's where it gets interesting, right? The study found something surprising about the connection between day and night heat.
That's the really fascinating bit. They found no strong correlation between the cities that had really intense daytime heat islands and the cities that had really intense nighttime heat islands.
Whoa, okay, so a city could be scorching hot during the day compared to its surroundings, but maybe not so much warmer at night, or vice versa.
Exactly. It strongly suggests that different things are driving the heat buildup during the day compared to what's keeping things warm at night.
So it's not just one simple heat island problem. It's like two distinct problems almost.
Precisely. Two different mechanisms at play.
All right, let's break that down then. What did the study say cranks up the heat during the day?
Overwhelmingly, the biggest factor was vegetation, or rather, the lack of it.
Lack of green stuff.
They found a really clear negative correlation. The bigger the difference in green cover trees, parks, grass between the city center and the suburbs or rural areas, the lower the daytime heat island effect. So more green equals cooler days, relatively speaking.
That makes intuitive sense, shade and all that. But is it just shade?
Shade helps, definitely. But the main cooling mechanism from plants is something called evapotranspiration.
Evapo what now?
Evapotranspiration. Think of it like plants sweating. They release water vapor from their leaves, and that process pulls heat out of the surrounding air. It's nature's air conditioning.
Ah, like a natural cooling system.
Yeah.
So fewer plants in the city means much less of that cooling effect.
Exactly. And interestingly, other things people often talk about, like the reflectivity of surfaces, the albedo.
Right, like painting roofs white.
Yeah. That mattered, but it was less significant than the vegetation difference for daytime heat in this global study. And things like population density or just general human activity didn't really explain the daytime SUHII either.
So daytime is all about the plants, or the lack thereof. Okay, then what happens when the sun goes down? The plants stop doing most of that evapotranspiration cooling, right?
Pretty much. And that's when the other factors really take over for the nighttime heat island.
So what keeps the city warm after dark?
Two main culprits identified by the study: stored heat and anthropogenic heat flux.
Stored heat. like the buildings and roads acting like radiators.
You got it. All those dark surfaces, asphalt roads, dark roofs, concrete walls, they act like giant heat sinks. They absorb solar energy like crazy all day long.
Just soaking it up.
And then after sunset, they slowly release or radiate that stored heat back out into the environment all night, keeping the city warmer than the countryside, which cools down faster.
Like a huge, slow-release heat pack covering the whole city. Okay, and the second thing, anthropogenic.
Anthropogenic heat flux. Fancy term, but it basically just means heat generated by human activities.
Ah, like car engines, air conditioners running, heating systems in buildings, industrial processes, all that stuff.
Exactly, all that waste heat pouring out into the urban environment. And the study used a clever proxy to estimate this.
Oh, yeah. What do they use?
Nighttime lights. They use satellite images of city lights at night.
Makes sense. More lights probably means more buildings, more activity, more energy use.
Precisely. And they found a positive correlation. Brighter nighttime lights were linked to warmer nighttime temperatures. More human energy use equals warmer nights.
That's really neat. Did they mention anything about seasons? Does it change summer to winter?
Yeah, they touched on that. Daytime heat islands tend to have bigger swings between summer and winter, especially in temperate regions.
Because of the vegetation changes, I guess. Leaves on trees in summer, bare in winter.
That's a big part of it. Tropical cities, where vegetation is more constant year-round, showed less seasonal variation in the daytime effect. The nighttime effect is maybe a bit more stable seasonally, driven by that stored heat and ongoing human activity.
Okay, this gives such a clearer picture. It's not just cities are hot.
Yep.
It's why they're hot, and that it's different day versus night.
Absolutely.
So let's boil this down. What are the absolute key takeaways for everyone listening?
Okay, first, the urban heat island effect is definitely real. It's widespread across the globe, and this study focused specifically on the land surface temperature differences.
Right.
Second, daytime heat islands are driven more than anything else by the lack of vegetation compared to surrounding areas. Less green, hotter days.
Got it. And
Third, nighttime heat islands are influenced mainly by two things: heat stored in all those urban surfaces like concrete and asphalt, and the heat released from human energy used traffic, buildings, etc.
and maybe the most crucial point,
Yeah.
because the drivers are different.
The solutions need to be different too. Tackling daytime heat isn't necessarily the same as tackling nighttime heat.
Which means there's no single magic bullet solution for every city.
Exactly. It depends on the city's climate, its layout, its specific challenges. Planting trees is huge for daytime cooling, but might not be enough for nighttime heat if you still have tons of dark surfaces and waste heat.
So here's something for you, the listener, to maybe think about. Given these distinct drivers, daytime vegetation, nighttime stored heat, and human activity, what could actually work in your city or your community?
Yeah, what are the most practical, impactful strategies? Is it about massive urban greening projects?
Or is it more about changing building materials?
Yeah.
Lighter colored pavements, green roofs, maybe tackling energy waste from buildings and transport?
It really prompts you to think locally, doesn't it?
It does. Maybe a good next step for you is to look into what your own city or region is doing. Are there local greening initiatives? Is anyone tracking the impact? Because effective solutions, as this study shows, really need to be tailored.
Understanding the why behind the heat is the first step to figuring out the what to do about it.